Again, welcome to Introduction to Data Science. This is R for Data Science. Again, we are going to continue with the visualization lectures. So again, this is visualization lecture number 3. Our main objective is data visualization with R. So here again, we are going to take a look at a bar chart. And again, a bar chart normally is very, very simple. We can also use Excel again to develop a bar chart. So as usual, again, we use the ggplot. Again, the same package for our data visualization with R. So here we say, but they are interesting. Again, the bar charts are very interesting because they can reveal something about a plot. So consider a basic bar chart as drawn with a geom bar. Again, the geom bar is a function. And the following chart will display the total number of diamonds in the diamonds data set. Again, the same data set we used previous lectures. And is grouped by the cut. Again, the diamonds data set comes with a ggplot2 package again, and contains information about approximately 54,000 diamonds, including the price of the diamond, the carat, the color, the clarity, and also the cut of each diamond. Again, when you download and install the ggplot2, again, you have the diamond data set with us. So here we have the ggplot. Again, our data is the diamonds, and we are using the geom bar for again to get our bar chart. So again, the same function we are using a mapping with the EX. Again, we are using the attribute or the column cut. Again, cut is one of the attributes of the data set. So this is what we have. Again, we are using the cut. And when we look at the data set, we will see that these are the possible information for a cut. So we may have a fair, good, very good, premium, and ideal. The best way again to see this data, I think in the previous lectures, we already used this data set. So if you download and install the ggplot2 and go to the folder of the download folder, you will see again the diamond files. There are some other couple of files there. And you can again study the file or the data set for the diamond and study the data. But again, you see that the cut attribute, these are the possible, again, values. Here we are creating a bar chart that will tell us the number. For example, in this very data set, when you go to the cut attribute, the only information you get is either fair, good, very good, premium, and ideal. Again, we can select any attribute, whatever value. But also, one thing is that the bar chart is good for nominal data, categorical data. I don't want to, for example, go to the diamond price, and I'm going to have a bar chart. Again, the price can be ranged from somewhere $2,000 to $20,000. In between, there are more than hundreds of different prices. So I don't want to create a bar chart. And also, most prices are not the same. So a bar chart will not be a very good idea for that. But again, we can also create a bar chart, whether it's a categorical data or quantitative data. So we can see in our column section is the count. So we know how many good we have is 5,000. How many premium? Somewhere close to 15,000. I would say somewhere around 13,000. So again, this bar chart, we have our X or the horizontal axis as a cut. And the cut consists of, again, as we said, these 5 categories. So on the x-axis, as we said, the chart will display the cut. And that's a variable or the field from the diamonds data set. And on the y-axis, again, it displays the count. but the count is not a variable. Again, it's not a variable. So where does the count come from? Again, many graphs like a scatter plot can plot the raw values of your data set. And other graphs like bar chart will calculate the new values. So here we are creating a bar chart, and we selected the cut, and we give the option to have the number of count in each cut categories like premium and etc. So again, let's go. So we have, for example, premium, ideal, very good, good, and fair. And so when we look at our chart here, we can see that again. First of all, we say ggplot. Data is attribute name, and the data will tell us the file. So the data set, the name of the data set is Dymos, the file name. Then we are using the geom bar. This is for, again, for bar chart. And now we said mapping AEX, and the x-axis, the horizontal should be cut, and the cut is a variable in the Dymos. So as we said, we calculate a new value for the plot. So bar chart, histogram, frequency, polygons being your data, then plot bin counts, or the number of points that fall in each bin. A bin is a bar. So if you are using a bar chart, or you want to plot, histogram is almost same as bar chart. The difference between the two is that histogram, there's no interval between the bars. Bar chart, we can have it, histogram, we can have a space between. Then we also have the frequency polygons. And this, they are bin to your data, and then the plot bin counts. We count the number of points that fall in each bin. So in our bin here is the ideal, good, very good, etc. Premium. And also smoothest fit a model to your data and then plot the prediction from the model. Also, box plot can compute a robust summary of distribution and then display the specified formatted box. Normally, the box plot can give us something like the minimum value in the data set, the maximum value in the data set, the Q1, Q2, and Q3 concept. So again, in this section, we just want to describe different type of visualization tools we can use. So the algorithm used to calculate the new value for the graph is called a stat. It's called a stat. We talk about the count. So short for statistics transformation. And the figure below describes how this process works with the geom bar. And then remember, we use the geom bar with the AES. So first, we have the geom bar begins with the Dymos data set. Then secondly, the geobar will transform the data with the count stat, which return the data set of cut values and counts. Then the geobar will use the transform data to build the plot. So cut is mapped to the x-axis, then the count again will be mapped to the y-axis. Again, this is done by the geobar, which is again the function for plotting the chart plot. So we can see our data set here. It's transformed. It gave us a new count. We selected the cut. So the cut is this field. The possible values for, or the possible items for cut is only 5. Idea, premium, good, premium, good, etc. So the list, again, this is a short version of the data set, but the possible information. So that's what we have here. Then the system will transform the data with the count stat to count each category of the values for fair, good, etc. and transform it for us. So here you can learn which stat a geom uses by inspecting the default value for the stat argument. So for example, I can have a question mark geobar. This is a help. So question mark geobar shows that the default value for start is count, which means that geobar function uses the start count function. Then the start count function is documented on the same page as geobar. And if you scroll down, you can find a section again called computed variables. This will describe how it computes two new variables, for example, the count and also the prob. So here we say you can generally use the geoms and the start interchangeable. For example, we can recreate the previous plot using start count instead of geobar. And as an example here, so we have the ggplot. The data again is our diamonds. Now, instead of using the geobar, we say the start count. Then we map in AES X equal to the cut variable. So we use the cut variable from the diamond. And this will give us the same graph again. So that's another option here. Instead of using the geobar, we can just use the start count function. This will work because every geom has a default start, and every start also has a default geom. So this means that you can typically use geoms without worry about underlying the start transformation or statistical transformation. And again, there are three reasons you might not need to use a start explicitly. So one reason, you might want to override the default start. Again, in the code below here, we can change the start of geobar from count, which is the default, to identity. And this will let me, again, map the height of the bars to the raw values of a Y variable. But again, unfortunately, when people talk about bar chart casually, again, they might be referring to this type of bar chart where the height of the bar is already present in the data, or the previous bar chart where the height of the bar is generated by counting rows. So this is just a demo. We have the triple, remember we have the cut, and then the frequency. So the cut, these are the possible information. The fair is 1610. Okay, frequency is like total tally, or the count. Frequency is the same as count. So we have the good, the amount, very good, the amount, premium, the amount, ideal. Then we use our ggplot again. Remember, we have the data here, and we assign the left arrow with a bar means we are assigning our data here to a demo object. So that's why this time our file name is demo. This information is inside. So we say data equal to the demo. Then we are using the geobar with the mapping, and we are setting the S cut. This time we specify the Y to be the frequent. And also our start will be the identity. So when you produce, this is what we get. Remember, we have the cut for X and frequency for Y. Here we don't need to worry that having seen the left arrow and the dash or the triple before. Again, we may see this as lectures goes on. The left arrow and the dash together, no space between. It's more or less like assignment operator. And we may again discuss that later on. The second option, again, you might want to override the default mapping from transform variables to aesthetics. So this is the example here. If I want to display a bar chart of proportion rather than count. So here I use the ggplot data again. We are using the diamonds. file. Then we have geobar, the mapping, we map X to cut again. This time the Y start to plot proportion. Then we group it by 1. So another option, you might want to draw great attention to the start transformation in your code. For example, you might use start summary, which summarize the Y values for each unique X value to draw attention to the summary that you are computing. So ggplot data, again, our demo data. This time we are using the start summary and we map our X and Y. This time our Y is depth. Then we have the minimum for Y, the maximum for Y, and also the median for Y. And this is what we have now. So we have again, cut we know is 5 different categories. But remember, we specify we need the depth. And also we talk about the minimum, maximum, the median. And that's the dots here, median. Then the maximum and the minimum. So ggplot provide over 20 stats for you to use. Each stat is a function. So you can get help in the usual example, use the question mark start bin if I don't need the help with the start bin. Also, we can do a position adjustment in our bar chart. So here we said there's one more piece of magic associated with bar chart. You can color a bar chart using either the color aesthetic or more usefully, you can use the fill. So to change, and we can see the options here. Previous, we create our bar chart and we change it with, and we fill it with colors. So we start with the ggplot again, the data we are using Dynamo to create our bar chart. And we use the S for our cut horizontal, and then our option, the color is cut. We are going to again color the cut. Then we have ggplot data diamonds again, geobar mapping, S is equal to cut, then fill equal to cut. So either we can specify the color to the cut or the fill, as we said. And when we run this, this is again what we have. So here they say we should know that what happens if you map the fill aesthetic to another variable like clarity. In this case, the bars are automatically stacked, and each color rectangle represents a combination of both the cut and clarity. So it will be ggplot data, again, diamonds, geobar, mapping, as filling with the clarity. Previously, we already have the color. So now we are filling it with clarity. So the stacking normally is performed automatically by the position adjustment specified by the position argument. Now, if you don't want a stack bar chart, you can use one of 3 other options: identity, dodge, or fill. So position equal to identity will place each object exactly where it falls in the context of the graph. This is not very useful for bars because it overlaps them. To see that overlapping, again, we either need to make the bar slightly transparent. So that's to make us see again the overlapping. And in this case, we need to set the alpha to a very small value. Or if we need a completely transparent, by setting the fill to NA. So this means no color. So this is the example here. So again, we have our demo. We are using the same demo data set. Our mapping, we have the cut for X. We say the fill is clarity. Now we use the geom bar, but this time we set our alpha to 0.2 or 1/5. So again, here we have the ggplot data for the diamonds. Again, the cut x-axis and the fill this time is clarity. Now, when we set the alpha to a small value, 1/5 here, we can see our result we are getting. We can see through the stack. We set their position to identity. The second option, again, you can see that is the same thing, but what we are doing is that there's no more color. So the fill, we say is NA. So that's the right graph we get. So we can see that there's no any filling or color in the bars. So this is 100% transparent. So again, in this lecture here, we are again using the bar chart, the possible options, properties that it has, which again, for example, either we can stack it or use colors to fill in. We can use the fill or color. So position is fill works like stacking also, but makes each set of stack bars the same height. This makes it easier to compare proportion across groups. So ggplot data again, diamond, geom bar, we have the S for cut, fill for clarity. The position now we say is equal to fill. So this again, fill works almost same as stacking also. We can see our results, different color stacking, but makes each set of stack bars the same height. So we can see the stack bars, their height are the same. Also, we can use the mapping called clarity. This time we are using position equal to dodge. And we can see the result. So here, using this, we can see that it gave us all the category of the values of fair, how all the values appears. For example, very good, these are all the values. So instead of combining all as one, separate it in each category. So here we say there's one type of adjustment that is not useful for bar chart, but again, it can be very useful for scatter plot. We should record our first scatter plot in our lectures. Actually, that was lecture 1. We noticed that the plot display only 126 points, even though there are over 234 of them. So again, you can avoid this grading by setting the position adjustment to jitter. Position equal to jitter. This will add a small amount of random noise to each point, and also spread the points out because no 2 points are likely to receive the same amount of random noise. So here we are using the MPG data set, which also again come with the package, the ggplot too. So we have geo point mapping. We set X to be this, then we set Y to be highway or HWY. S is again DISPL. Position, we are setting the jitter so we can see how the scatter plot looks. Because the jitter will add a small amount of random noise to each point. Also, adding randomness seems like a strange way to improve your plot. But while it makes your graph less accurate at small scale, it makes your graph more revealing at large scales, because this is such a useful operation. ggplot2 comes with again shorthand for geom plot, position equal to jitter, or geom jitter function. Now, to learn more about the position adjustment, we should look up at the help page associated with each adjustment. We have the position dodge, should start with a question mark. For the help, actually, the question mark is here. So question mark for help, or question mark position field, question mark position identity, question mark position jitter, and position start. Again, this will give you more information. So again, in these lectures, we went through how to construct, again, a bar chart using the R and some of the attributes. For example, the color, stacking, etc. So we have exercise here. Again, this exercise is an extra points for the course. So we're going to answer these questions. What is the default geom associated with start summary? How could you rewrite the previous plot to use that geom function instead of start function? Question 2, what does a geom column do, or geom COL do? How is it different to geom bar? Remember, we have in Excel even we have a column. Then we also have a bar chart or column chart. So that concept. Again, this is an exercise, so do your own short research. And also we are going to plot this data. So if you are submitting your work, make sure you have the graph also. So this is exercise 2. What is the problem with this plot? So you can give the answer. What parameters to geom jitter control? Compare and construct the geom jitter with geom count. And also we have question number 4. So we're going to end here for our lectures on visualization using R for lecture number 3. And in this lecture again, we studied the bar charts and some of the few properties or characteristics of it. Again, the exercise 1 and 2, you can submit it for extra credit points for the course. So wish everybody the best. Thank you.